Alrighty, Mr. Gatekeeper here. Here I have a 4-pill Toshiba Japanese soldiers. You'll probably wonder, why the heck is there blue dots on them, Gatekeeper? I could have took the blue dots off, but I didn't want to have to sit there and risk taking some of the Toshiba off. But I actually got these Toshibas from Mr. Tin Man. Mr. Tin Man over at the RF place. He gave me a shout and told me he had bought a couple of boxes of 25 and saved me a couple of bucks. Anybody's trying to save a couple of bucks, man, in this thing, you know, there ain't nothing wrong with that. So I got these Toshibas from him. Genuine Toshibas, came from RF Parts. I think they came from RF Parts probably a little bit back before they had increased the prices. I think that's how he was able to give me them just a couple of bucks cheaper. Not much, but anything saved is worth doing. But anyway, so we got you 4 Toshibas as promised. And this is a all-time AB biased amplifier. This is the first time I am enjoying a celebration cigarette. But as a lot of people have said, you know, why do you smoke around your equipment and all? I'm completely ventilated. If I'm smoking out here, I am ventilated. I don't let smoke just sleep around and get all over the equipment. I cannot stand being in a room with smoke floating all the way. It's a bad habit as it is. I don't need to be sitting in a room just breathing it in and out. But I work pretty hard on this thing to get it done as fast as possible, but to get it done right and take my time. But this is the first time that I've been able to implement a regulated AB circuit, which I want to demonstrate now. It is utilizing an old school Motorola style bias circuit using the reverse diode in the reverse direction. And it's a pretty this circuit's used by Motorola for many years. And we are biasing 4 transistors, and that's why I've got the extra 25-watt sandbar here. Okay, all 4 of these transistors are identically matched. They are identically matched. If they were not, I would probably have broke up the bias circuit into 2 parts, biasing each of the 2 sections. But since they are matched, all 4 of them turn on at the same exact voltage, I was able to do a bias circuit to bias all 4 at once. Every single transformer is matched. Yes, these 2 transformers are right there at the identical inductance. These 2, the capacitors, are identically matched. Every capacitor in the whole box is matched. It's an identical reading. All the 120s are sitting there exactly at 118 picofarad capacitance. They are matched. So I made sure to match when you're doing a biased amplifier, you really want to be strategic when it comes to matching, because you want that thing to, you want both 2-pill sections to work as well as they possibly can to with each other. All right, we implemented the preamp. You asked for a preamp, so we got you a preamp circuit right there, man, with invert circuit. So the cool thing about that is you can use the preamp when the amplifier is turned off. Okay, there is a bypass circuit, which is what the invert circuit is. It bypasses the preamp circuit itself. Okay, I will demonstrate that now. I haven't even tested that yet, but I know it works because I tested the preamp before I put it in here. Alright, we are barefoot now with a 4-watt radio. Alright, the preamp is on. Okay, I'm going to go ahead and show you now if you'll hear it bypass. Alright, I'm keyed, unkeyed. Alright, I know I got the 1000 watt slug in, but you can see a little movement. So you can have the preamp turned on when the amplifier is turned off and speak through it barefoot. Alright, and if you can see, I have a little capacitor. Do you see that capacitor right there? That is actually setting the ohms back to 50 ohms. Oh crap, don't tell me I just did that. I will be right back. I do that sometimes. I don't know how my phone does this. I never can figure out how to turn it back. I'll be right back. I was trying to do this video all the way without having to stop it, so I didn't have to merge 2 or 3 videos together, but it looks like I have no choice now. Don't always work out according to plan. But anyway, here is your flow through. Oh dear. Oh, perfect tune. I'm sitting exactly at 50 ohms. See, the problem is the RF has to come through here, okay, go in the relay, travel up this wire to this relay, in that relay, and at this point the keying circuit in the invert circuit actuates, gives this relay a ground. Then it has to flow the jumper on this relay back down this wire right here to this relay again, back in that relay, back out this white wire and out. So it's literally a through, up, through, down, back out, and going through all of that wire. See, wire is roughly around 100 ohms, roughly around 100 ohms if you look at it. Rolling through all that wire, it's going to throw off the impedance, because you got a 50 ohm coax coming through like that. You've got a break right here where you just have 100 ohm wire traveling in and out of devices. It's going to throw off the impedance a bit. So basically that's what that capacitor is doing in there. I could have put it there, or I could have put it down here, but it's easier to put it here on this jumper. So sometimes I have to do that, sometimes I don't. I needed to do that on this one. I could see there was a tad bit of differential there. Alright, I have this meter. Let me move these second hands. I have this meter hooked up to the bias section, okay? It's got it hooked right here, which is going to be feeding the bias this direction to these transistors. This is pulling right there at an idle current from the collector back. Brain's messing up here. The transistors are pulling an idle current at idle when keyed. Right there at 100 milliamps. So that is in the conduction of AB bias, right there at the conduction angle of AB. And as long as you keep this amplifier good and cool, don't let it get too hot, everything will be fine. The only thing that you can do to, at this point, to make the bias circuit better is to start implementing temperature compensation, stuff like that, which that's something I've been studying for a while. I've had a interest in biasing circuits because I am such a sideband operator as well. I am a hardcore sideband operator as I am an AM operator, so you know I want to learn it all. But as long as you keep the box cool, you won't need a temperature compensation circuit. So just want to keep it cool as you possibly can. I just want to show off the regulated part. See, the problem with bias amplifiers like Texas Stars is once you start to run them on higher voltage, then the biasing voltage comes up, which means the current comes up as well, okay? And then once the current increases on these devices, they're going to start running hotter and hotter, and then you're going to bust into a thermal runaway situation or an oscillating situation where you're going to lose a transistor or maybe more. So that's one of the biggest issues why you cannot run Texas Stars, you know, above a certain voltage. Now, just because this has a regulated AB circuit in it does not mean that you're just okay running it on an 18 plus, you know, not 20 volt supply. That's not what that means. It just gives you a regulated area. If you do go a little bit higher in volts, that it's going to keep this bias where it's at. It's going to keep it regulated. You know, so it's still not a good idea to get crazy with it and take it here and there. It's just adds a little bit of safety. Let's just put it that way. All right. I just have this hooked up to the supply right here. Okay, the servo supply. It's not big enough to really key it or anything. I just want to show the bias circuit. All right. So I have that meter hooked up. This right here I have hooked to ground so that I can manually key the amplifier like this when I have the amp turned on. Like this. Okay. Alright, we are sitting on 15.3 volts. Okay. Alright. We're on the 2 volt division of DC voltage. I'm going to try to make this quick. Alright, I'm now going to manually key it, which sends voltage through the bias circuit. We're at .67.5 volts. Beautiful. Beautiful. Show you, I'll go over to the 20 watt scale. .66, .65, .66 volts. That is a good place to be. You want to be right there around .64 to around .68. Once you go above .68, it pretty much lets you know you're getting a little bit high in the current and all that good stuff. Now, question is, I am using a 12 volt regulator for the biasing, for the regulation part of this. A lot of people may use a little bit lower 9 volt or a 5 volt regulator, etc. But I did implement a 12 volt regulator for this circuit. Now, what if your car voltage gets a little bit too low? 12.6 volts. Luckily, the particular regulator that I am using has a slight of a boost circuit in it that will boost the voltage just a bit to keep it where it needs to be. But the cool thing about it is, you see we're at .62 volts. The cool thing about it is it's okay to go down in voltage. You don't want to go up. So that all that does right there is bring you a little bit down the biasing range. And if you get there around, give you an example, if this was a B bias circuit, like for example an X-Force B bias circuit, or I think BBI uses some B bias circuits as well. I have not yet played with any, but there is a good place for a B bias circuit. I won't get into all that on this video, but if it was a B bias circuit, you pretty much would see the voltage right there around .35 to .38, .4 volts, right around there. All right. So if your voltages done went low in your mobile for some reason, you're still good. You're still in a good, safe operating region. All right. Give me 1 second. Now I'm going to go high. We're going to go to 18 volts on an unregulated supply. Give me 1 second. I'll be right back. Alrighty, we are now hooked up to 100 amp unregulated supply, as you can see. Okay. So now we have 18.2 volts sitting on this amplifier. As you see, that fan right there is regulated as well, so the fan is fine. Alright, so let's manually key. Let me turn it back to 2 volts, sorry. Let's manually key the box again. Look at that, .676 volts. Beautiful. Right there at the exact voltage that it was at when we were on 15 volts, and that is on 18 volts. Okay, Normally, if this was a regular, unregulated bias circuit, the way I've always done in the past, your current would be too high on 18 volts, and it could be very damaging to the transistors. Yes, it would drop when I key and all that kind of stuff, but your current would be way up. The voltage would probably be close to 0.75 to 0.8 volts. Once you put over a volt in these transistors, you can damage them very, very, very quickly. Very quickly. I've seen it happen in Texas stars time and time again. Alright, let's demonstrate. We're going to key this bad boy now, show you some output. I'm going to go ahead and unhook the mirrors. Get all these wires off this amp. Alright. Alright, we're going to be hitting it just with the 4-watt radio at first, which is hardly no drive. I understand, but we're just going to start there. Put everything up here, sorry. Alright. Alrighty. Alright, let's just sit that right there. Alright, so we got the 4-watt radio hooked up. I am on the unregulated supply. I need to get me a bigger regulated supply out here, which I will be taking care of here soon. But for now, we're just going to do a quick key on 4 watts. Like I said, it's not much drive. We're going to increase the drive after that. Okay. This is going to drop to about 15.5. All right, we're on the 1,000 watt slug. Okay. Oh, that's already about 160 watts RMS. I'm going to let you see the input tune. Oh, looks beautiful. Here's your peak already. Oh, already right there about 500 watts. We ain't even put no drive in this thing hardly at all yet. Alright, let's go ahead and increase the drive. We'll go ahead and hook up the hot radio. I really hadn't made my mind if I'm going to hook up a driver to this thing or not yet. I think, if I remember correctly, Mr. Matt, I think he said that he is going to be using, where's my coax at? For my radio. There it is. I think he said that he's going to be using a specific radio with this. Now that is another thing, since this is biased, y'all, this amplifier does not need as much drive to get up and going. By the way, I've got the sideband button on that whole time, but there's your sideband delay, okay? So there's your sideband delay if you're wanting to operate on sideband, which I know you will be with this bad boy. And I'm going to be testing it on sideband tonight and on AM. Alright, we are now on the hot radio. We are doubling our drive from 4 watts to 8 watts RMS. And I am seeing this for the first time with y'all. I have not even made it this far yet. I'm just joking with y'all. Alright. Make sure everything's hooked up fine. Go. Alright, we're good to go. So that's another thing about an AB biased amplifier. The amplification factor is turned up because you have bias voltage going to the transistors. So that means your dead key will be a little higher on a biased amplifier than a Class C. So 1 watt going into this box still gives us, look at this, 1 watt turns into almost 50 watts. That is amazing. Alright, we're on the hot radio now. Oh, goodness gracious. That is crazy, man. Oh, that's 14.3 volts. God, this thing. Woo! Let me look real close what that's doing. Oh, almost 280 RMS. And we're sitting at 14.2. Peak watts, already about 750 watts. That is something else. Take a look at the drop voltage. Voltage drop, sorry. 14.3 volts. That is amazing. So that is a cool thing about an AB biased amplifier. You don't need as much drive to get it up and going. Alright. Now, we are going to hook up our hot radio. We're going to put about 16 watts RMS into this thing, okay? 16 watts RMS, our D-rail radio. It does about 19. I got it turned down, the voltage turned down so it'll do 16. So we will see what this bad boy does with that radio. So we will be right back. I've got to hook the mic up to that one. I'm going to press pause. Alright, brother. We have the hot radio hooked up. The D-rail Cobra 29. Alrighty. Well, I am still on the medium tap, by the way. I have not turned it to the high tap yet. And I am pretty blown away with the results. Pretty blown away, man. I may just have to take this amplifier right here, man, and skip to Mexico, man. I'm gonna be honest with you. Nah, I wouldn't do that to you, but this thing is pretty remarkable. All right. Now we're putting 16 watts RMS, which is equal out to around, if I remember correctly, 50, 60 watts peak, maybe a little less. Let's turn the amp on. Alright. Oh, look at that. 320 watts RMS. That is unbelievable. Just hitting it with a Cobra 29, y'all. Oh. Take a look at the voltage drop. Oh, 13.9 volts. 13.9 volts. Excuse me one second. Let me turn up the voltage on this thing and the current from the medium tap to the high tap. Alright. We are now on the high tap. 21.2 volts float. I'm going to do a quick key. I don't know what it's going to drop to. I'm going to kind of just look over here at the voltage. Ooh, 15.7. I didn't see what it swinged. It's a little bit high on the voltage. I'm just going to do a real quick key again. Ooh, oh my God! That thing is doing 400 bird. Just hitting it with a radio. Woo! Sorry, I'm a little excited over here. I have never seen a dang 4-pill on my bench, or my table, whatever you want to call it. I've never seen a 4-pill do 400 bird, just hitting it with a Cobra 29. That is unbelievable. That is crazy, man. That is amazing. Peak watts. Oh, 1,000 watts in the corner. Yes, the voltage is a bit high on that. I would not run it at 15.7 where it was sitting at. Wow, I'm flabbergasted, man. That's amazing. That's good. That is good. I tell you, it pays off to take the time and match everything. These two transformers were picked from, I don't know, 12 to 14, 15 transformers to find the two that matched in inductance as close as possible. Same with these transformers. Okay. Got the RF chokes here, RFCs as they say them. Just trying to keep that ripple off the DC line going out. Okay, we utilized two 10-gauge wires, so pretty much a little bit, you know, thick 8-gauge, just to kind of spread it out on the. I'm happy, man. This turned out great. I am flabbergasted about that radio. That's amazing, man. That's good amplification factor, I will admit to you. 400 watts RMS, 400 watts, just hitting it with a Cobra 29 single final. radio. But that is a hot rod radio, and Mr. D-rail done a good job on it, man. I don't care how many people out there's got an issue with old D-rail. Hey, everybody's got an issue with somebody. I'll tell you like that. You can't keep everybody happy in this world, but that's a bad A radio right there, man. Of course, I know everybody wouldn't be. Basically, all that radio is doing right there is simulating a very small one-pill driver. If I hooked up my one-pill driver right there, it would be giving this amplifier about 40 watts RMS. More than twice the amount that one's giving it. And when I would hook it up, I know what I would see. I would see probably about 500 watts RMS. But look, this amplifier is not designed to be a big maul amplifier. It's not designed to be a big maul dropping amplifier. That's why I'm not going to hook up anything else. I could hook up a driver and then hook up my bench radio or my hot radio and show you 500, maybe even 600 plus watts. But that's not what this amp was designed for. This amp's designed to be a linear amplifier to be ran at a clean. Sorry, man, my mind's blown over here, man. But this amplifier is designed to be a linear amplifier. It's probably going to be used on sideband a good bit, and not to be overdriven with all them watts. Hey, man, run this amplifier easy. I'm going to test it a little bit throughout the night when I have time tonight, in between working. Keep the box cool. I picked a very high dollar fan. I know you wanted a blue LED fan on this. If this was my choice, I would have probably put a pretty thick fan on this thing, man, to just keep these transistors good and cool. I do have a little bit of an exercise heat sink on here that goes a little bit further than normal. It's a little bit longer of a heat sink, probably more like you'd use on a straight 8. But if you feel like you need more airflow, just put you a bigger fan on this thing. Like I was trying to say, I know you wanted an LED fan, so I went ahead and put an expensive LED fan on there for you so I can get as much airflow out of it as possible. I think that fan cost me roughly 18 bucks, I think. Maybe a little less, I can't quite remember, but it is a more higher end fan. It's pretty much the fastest LED fan I've been able to find next to a Yate Loon. But there she be, man. Let me get the top on real quick and put the screws in it, and I'll be right back. Alright, brother, well, there she goes. I was going to put the screws in it, but I want to take a few pictures of it before I do. I can't remember if I took pictures of when I just the final production of it. I can't remember, but it's a pretty expensive little top here. I had bought it from a computer store a while back. I can't remember, 15, 16, 17 bucks or so. I liked the way it looked because it was blue. I thought it'd be cool to use on on one of the painted boxes. I was just kind of holding on to it, but you know, I know you waited a little bit longer than anticipated than we planned, so I thought I'd throw it on there for you, man. And so there she is. All right, brother. Look, somebody's here. What's up?
How you doing, sir?
Yeah.
My name is Derek Williams. I'm in the warehouse here for real. I need a little bit of help today. I had two guys supposed to be at work today and they didn't show up, and I wound up missing up.
Sorry about that. I had somebody pop up over here trying to sell me something. I told him, shoot, you at the wrong place, but so anyway, there's the back of it, bud. So there she be, man. Well, I hope you enjoyed, man. I hope it lasts a long time for you. It was fun building it for you. I definitely would love to take time to build me something like this, man. This would be just right up my alley for being a hardcore sideband operator. Boy, I could have some fun with this box. One of these days when I get a little bit of time, I definitely will make some time to build me one. Alrighty, bud. There it is. Hope you enjoy, man. We'll see you. Bye-bye. And anybody out there that's waiting, just continue to be patient with me. As you can see, I'm working hard as I can. That's all I can do. I'm a one-man show, trying to get them out the dough. Hey, that's a new saying right there. I think I'm gonna stick to that one. One-man show, trying to get them out the dough, and I'm gone. Bye-bye.